All right, gonna try this part 2 here. I'm gonna do this in a couple of different parts, part A, part B, but this is lesson 2.1. We're learning all about quadratic stuff now. In the vocabulary, the biggest thing that came up was line of symmetry. What does it mean by line of symmetry? Line of symmetry is basically what divides something in half. So I'm gonna skip ahead here to this parabola. Your line of symmetry is gonna end up being that line that divides this parabola in half evenly. So if I take the left half and fold it over on the right half, you would only see half of it there. This point would be 3 units to the right, there would be 3 units to the left, 2 units to the right, 2 units to the left. That's what symmetry is. So now as we move on, we talked about what is the domain of the function. If you pause a second and read, basically grandma's building a quilt for her son. If grandma's built for her grandson, if grandma builds a quilt for her grandson, the domain of this, if you look at this as a coordinate plane, can only exist over here. The reason why is because you can't build a quilt out of nothing. So the domain in this aspect is going to be 0 to infinity, and it's going to not include 0, it's got to be greater than 0, and it's going to include all of those other numbers. All right. Number 2. Match each statement about the area of the function it models. We have to change our thought process when we go through and look at these. When we said at the very beginning of the year, we talked about finding the area of a basic square. Well, let's see if we can figure out what's going on here to match. Number 1, I found the area first. Think of order of operations of what you have to do. You have to square it first and then multiply by 5. So which one do we find the area first and multiply it by 5? The area first multiplied by 5, that's D. Use that one. The next one here, am I squaring it or adding 5 first? I'm adding 5 to the length of a side. So this would be x plus 5, x plus 5. I'm adding the length to the side, then I square it. So the length of a side is increased by 5, then I square it. That's A. Down here, I'm taking the length of a side. All right, so here's my basic square, and it's going to be 5 times x. And then I'd find the area. So it'd be 25x squared if I were to do that. So the length of a side is multiplied by 5, so that's B. And then lastly, C would be the area is increased by 5 units. Down here, question number 3, right? We're comparing. What can we compare about the graph and about the parabola? Well, we talked about some stuff. I'm not going to kill it with a whole ton of stuff, but we can see decreases and we can see increase. You're on the roller coaster. Roller coaster comes down, roller coaster goes back up. That's increase, decrease. We also talked about a minimum value. Right? It's going to have a minimum value down at the bottom. All right? We can see the increase, decrease too, by the way. Right here, 9, 9, 4, 4, 1, 1, and 0's in the middle. We can see the decrease there. They both have an x-intercept of 0. You can find that by looking at the graph. You can also find that by, hey, they meet in the middle. Think about it. They're symmetrical. All right? That's kind of enough for that. I'm gonna move on from there. The next thing we looked at was where we wanted to compare this equation with y equals x squared. What's similar, what's different? Well, in order to do this, we're going to look at 2 things. One, we're going to look at how do we state this equation? How do we kind of state this? Well, again, what do you do first? We square it first, find the area. So we're going to add 5 to the area. That's what happens. That's a horrible looking area. You're not going to be able to read that. A-R-E-A. The area. We add 5 to the area. Now, in order to see what happens when we add 5 to the area, we need to go to Desmos.com. So on your Chromebook, pause it, go to Desmos.com. I'm going to do that here real quick, and then I'm going to throw it back up there. You want the graphing one. And you should be familiar. It should look like this. First thing I want you to do is input y equals x squared. If you put in y equals x, you can see it has a line. In order to get the square, you're going to hit Shift 6, and you'll see it. It'll move the cursor up into the exponent, and just put a 2 there. All right? So there's your parent function. That is your parabola. Now what you need to do is put in y equals x squared plus 5. So y equals x, Shift 6, square, and it'll cover up that parabola. Arrow over, so you get the cursor back out of the exponent, and then you're simply going to put plus 5, and what did it do? What happened? What happened from my parent function to this one? And you should sit there and say, well, gee, it just shifted up 5 units. Yeah, you're absolutely right. So go ahead and copy that down right here. It shifted up 5 units. So now we can compare the similarities and differences. And this video is going to be over here fairly shortly. They're both parabolas. Right? They're both going to have a minimum value. They're going to have the same line of symmetry. So remember how I notate stuff, because I don't want to write the word line of symmetry all the time. Capital L, lowercase o, capital S is x equals 0. Right? It's always a line, never just a number. They have the same stretch. In other words, the example I used in class was the example of a rubber band. Think of a rubber band. If I stretch a rubber band, that rubber band's the sides are going to get closer together. That's what we call a stretch. If I shove it closer together, the sides are going to widen. That would be called a shrink. So in this case, it did not do any of that. So they have the same stretch. What's the difference? The parabola shifted up 5 units. That's what happened. Okay? And then another difference is it has no x-intercept. All right? So that's something, the differences for there. So that ends part 1, and then we'll talk about part 2 in a second.